All right, so we left off on number 5, and so we're graphing these, and so we start by figuring out what is the behavior, my end behavior. Basically, as x goes to infinity, which is over here, what happens to my y value? Does it go up to infinity also, or does it go down to negative infinity? So that's what I'm trying to figure out, the behavior over here. And so I just focus in on this. And so if I plug in infinity, or basically a large x, positive x value, what happens? Well, what's going on here is this is really negative 1 times x cubed. And so when I plug in a positive number to a third power is positive, but then it gets multiplied by this negative 1, so I get negative results. So as x grows positively, the y value is actually going to grow negatively. So this tells me that when I hit my last x-intercept on my right side of my graph, I'm going to go downward. Then the left end behavior, which is this, as x goes to negative infinity, we're going to look at what's the behavior of y. So once again, I plug in a negative x value, big negative number, whatever you want to plug in, and a negative times a negative, oops, we're multiplying the negative together 3 times. And so a negative times a negative will actually give me a positive, but then a positive times a negative will give me a negative. So I end up with a negative number, but we're multiplying it by a negative 1 on the outside, so you multiply it by a negative number one more time. So you multiply it by a negative number one more time, and when they multiply together, it does result in a positive. So this is going to go towards positive infinity right here. So that when I hit my last x-intercept on the left side of my graph, I'm actually going to go in upward. I'm going to go upward. My y value is going to grow positively. Okay, so now that we know our end behaviors, now we have to find the stuff in the middle. We have to find the x-intercepts. And so we're going to start by finding those and then categorizing them as crossing or touching the x-axis. So find the x-intercept, we're going to let y equal 0, or in this case f of x. So let's see, we have negative x cubed plus 6x squared minus 9x, and we're going to set that equal to 0. And I'm going to start by factoring out, to make my life a little bit easier, I'm actually going to pull out a negative x. So that's going to change all my signs here. So this becomes positive x squared minus 6x and then a plus 9. Okay. And then what I have in parentheses here can get factored. And they're going to factor into x minus 3. So I'm going to have x minus 3 and x minus 3. But whenever we have common factors like that, we can go ahead and bring that together and write it as x minus 3 squared. And it's important that we do that because that helps me know my multiplicity. And that helps me categorize this. So my x-intercepts, they cross if my multiplicity is odd, and they touch if it's even. And so my multiplicity on this x-intercept right here, my solution to this is 0, and that multiplicity is of 1. And so that's an odd multiplicity, so that's going to go here, right? Then let's see, my other multiplicity here is going to be positive 3, but its multiplicity is even, it's 2, so that one actually is going to go down here. So I have another x-intercept at 3, but it's going to touch, okay? And so just to kind of review this, multiplicity, if your multiplicity is 1, it kind of goes through the x-axis and just kind of goes straight through it, almost like a straight line. If your multiplicity is of 2, then what happens is it kind of bounces off. It almost kind of has a parabola shape to it where it hits the x-axis like that. And then if you have a multiplicity of 3, which we might come upon later, that one actually kind of looks like a cubic function. It kind of curves in and out where it hits the x-axis. It does cross, but it's a little different than the multiplicity of 1. It kind of has a little curve in and out of it. And then the last part was the y-intercept, which is pretty easy because if you let x equal 0, 0 cubed plus 6 times 0 squared, they all have x's, and they're all getting multiplied by 0, so my y-intercept is just at 0 right there, so that's pretty easy. And that's going to be the case for most of these, by the way, is our y-intercept will be 0. So let's see, our x-intercepts, we have one at 0, and we have one at 1, 2, 3. And we're just kind of trying to build this the best we can right here. And then what I know about 0 is it's just going to cross right through. It's just going to go right through. And my left end behavior right here tells me that when I cross through my last x-intercept on the left, my y value is going to go up towards positive infinity. And once again, it's kind of like a straight line. So you can just kind of do it like that. It's moving left, so you want to tilt it to the left, but it's going up at a pretty fast speed. Now, my x-intercept on my right, which is at 3, that has a multiplicity of 2. So it's going to have that kind of parabola shape to it. And I know that my y value should be going in a negative direction. So when I hit this last x-intercept here on the left, I'm actually going to kind of curve it down like this. I'm going to kind of give it a little curve, like half of a parabola. Because what's going to happen is this is going to curve like this and go down and come back up through here. And so that's the last part I have to figure out is I want to figure out how far do I dip down? How far should I dip down? And so what I need to do is I need to plug in 1 and 2 into my function to figure that out. I would just plug it into the factored form right here. I would just go ahead and take this and plug it in here. So like f of 1 would be equal to negative 1 times 1 take away 3. Or you know what? I could actually plug it into the one underneath it. Actually, this one right here. That would be a little bit easier. So then let's see. 1 take away 3 is negative 2 and then squared. So I'm actually plugging it into that one. Okay, so negative 2 squared becomes it actually becomes positive 4, and then negative 1 times positive 4 is negative 4. So I know at 1 I should be at negative 4. So let's see, negative 1, 2, 3, 4. So about right here. And then let's see, what about f of 2? Let's see, f of 2. Let's see, so that's going to be negative parentheses 2. And then 2 take away 3 is negative 1. And then we're going to square it. And so let's see, this becomes negative 2 times 1 because the negative 1 squared becomes positive. Negative 2 times 1 is negative 2. And so let's see, we're going to put that about right there. Okay, so now I can kind of draw this so it curves in and then curve it again. You don't want to have any sharp turns, so do the best you can to kind of have this to where it's got smooth curves. We don't want anything sharp right there. And so end up with something kind of like this. Like I said, it doesn't have to be, you know, super pretty, but you want to make sure you're accurate and do the best you can to have that curve to it. All right, let's see. I think I've got a couple more of these. Let's see. Okay, one more of these. And so what we'll do here is same thing. So in behavior, we look at this and we say, okay, let's see. If I plug in a positive number and raise it to a power of 4, I'm going to get a positive result. So basically, as x goes to infinity, y is going to go up to infinity also. Then over here, let's see, what if I plug in a negative number? Well, a negative number raised to the power of 4 will actually come out positive. It will come out positive because a negative times a negative is positive, but then times a negative will turn it back, and then so on. So anyways, any negative number raised to an even power will always come back positive. So this is actually going to be positive also. So as x goes to negative infinity, y is going to go to positive infinity also. The y value will go to positive infinity. So what we have to do now is find those x-intercepts. So my x-intercepts, we're going to let y equal 0, or f of x. So let's see, we have x to the power of 4 plus 3x cubed. We'll set that equal to 0. And so let's see, on here we'll factor out an x cubed, and that will leave us with x plus 3 equals 0. And so I have two unique solutions. My first solution is 0, and my second solution is -3. Now, they both have odd multiplicity, so they actually both belong into the cross category. They're both going to cross. I don't have any that touch and turn around like we did on the previous one. Now, the one at 0, though, since its multiplicity is a 3, it kind of has this shape to it, or it could go the other direction. It could go like that. So it's going to somewhat have that like cubic twist to it. And then here, this one has a multiplicity of 1, and those just kind of look like straight lines kind of going through your x-intercept. Once again, my y-intercept is just going to be at 0 right here, because if I plug in 0, those go to 0. So let's go ahead and plot those x-intercepts. So I've got one at 0, and then -1, 2, 3. There we go. So anyways, I've got one right here. Okay, so from what I can tell from my in behavior at 0, I'm going to kind of have that twist. I have that twist. And as I go to the right beyond my intercept, y is going to go towards positive infinity. So this should kind of have kind of almost like a parabola twist to it, and then it's going to kind of have a twist to it going down right there. And I'm going to figure out how far down we go in a second, because we're going to plug in -1 and -2 in a second. And then at -3, as I go through -3 and I head towards the left side of my graph, y is going to go up. So I know that this is going to basically kind of look like this. It's just going to be a straight line. It's not going to have that twist to it like we did on the other side. And this is all due to the multiplicity of where my solutions are at. So the last thing we want to do, and I'm just going to take this right here and evaluate the function at f of -1. So let's see, that would be -1 to the power of 3 times -1 plus 3, which would be a 2 to the power of 1, which is just 2. Well, let's see, -1 cubed stays -1 times 2, which then gives us -2. So I'm going to dip down to about right here or so. And then let's see, what about f of -2? Well, f of -2, let's see, we're going to get -2 to the power of 3, and then times -2 minus 3 is, or plus 3 is 1 to the power of 1. So this one's going to give me -8 times 1. So I'm going to dip all the way down to -8. Okay, I'm actually going to go back and maybe adjust this a little bit. What I'm going to do is I'm going to go by increments of 5. So 5, 10, something like that. So -5, -10. So let's see, my first one, let's see, so that one's at -2, so that's about right here. So I'll have to maybe clean that up a little bit. And then at f of -2, I'm down here at -8, which would be about right here. So here we go. So this is going to curve, and then it's going to kind of bowl out at the bottom. It's going to kind of be a bowl shape right here at the bottom. And there we go. All right, I'm going to go ahead and pause the video here and make another one for the next couple questions.